In this video we're going to look at polynomial functions. For our first example, we're going to determine whether the function is a polynomial. So we'll have f of x equals 7 minus 2x. Okay, to see if it's a polynomial, first we look and make sure that all the exponents are whole numbers. A whole number is a number that's 0, 1, 2, 3, 4 and greater. It can't be a negative number, it can't be fractional. So in this case we have x is to the first power, so it is a polynomial. And as far as degree is the highest exponent in any term, which in this case is 1. So we have degree is 1, which is linear. As far as the number of terms, we have this is a term and this is another term. So we have two terms, which would be binomial. Okay, let's try another one. We have h of x equals x to the fourth minus x to the minus 5. Well, in this case, we have a negative exponent, so it's not a polynomial function. And the equivalent of that is x to the fourth minus 1 over x to the fifth. It's a function, but it's just not a polynomial function. Okay, let's try something else. What I'd like to look at is end behavior of a polynomial. So as x approaches plus or minus infinity, what's the end behavior of the function? So for that, we'll take an example. Function of x equals 2x to the fifth minus 7x squared minus 4x. Okay, we only have to pay attention to two things to determine this. And one is the exponent for the largest term, the term with the largest exponent, is it odd or even? And the leading coefficient, when we have it in standard form like this, the leading coefficient, is it negative or positive? It's positive. So if we have a, so then the question is, function of x, as x approaches, let's say, negative infinity. Okay, so as this x approaches negative infinity, it's an odd number, so it's not going to be a negative times a negative, so it will approach a negative. So as x approaches negative infinity, this term approaches negative infinity. And then the leading coefficient is positive, so that's not going to change that. So the function of x approaches negative infinity. Okay, as x approaches positive infinity, so positive infinity, this will end up being a positive infinity because it's an odd exponent, and then times a positive leading coefficient. So function of x will approach positive infinity also. So that's an example of end behavior, because this term has the largest exponent, so it's going to swamp out the values of anything else. These are small potatoes compared to this leading term. If we were to graph this situation here, As x approaches negative infinity, the function approaches negative infinity. Let's take and make a sketch of that. So as you think of out here on the x-axis, that's approaching negative infinity for x. And the function is on the y-axis. So as x approaches negative infinity, we just concluded from the function that the function of x, which is on the y-scale, approaches negative infinity. So it's way down here. And then I'm not exactly sure where it changes, but as the x approaches positive infinity over here, the function, or the y-scale, approaches positive infinity. So that is roughly the shape that the function would take on a graph.